All right, I had to change the lighting a little bit, but this is circuit A. Now, switch 1 did not show up to work today, so switch 1 is going to be represented by just taking this alligator clip and connecting it to the batteries here. You'll see this is bulb 1. So switch 1 is here, bulb 1. Here's switch 2, that's the one that's going to matter in this. And here's bulb 2. And so when I connect switch 1, then we see with switch 2 open, both bulbs are dim, but closing switch 2, bulb 1 gets bright, bulb 2 gets dim. So this is important before we plug in the capacitor, and I would have a conversation with your students about this. Why are these equally dim, but now this one is bright? You can have conversations about what a short circuit means, or the loop rule, explaining how all the energy is delivered to bulb 1 when the switch is closed, or the energy has to split, whatever you need to do. But make sure you show them this first, and then you can just remove switch 2 and replace with the capacitor. Now I'm going to take off switch 1 right now, and I'm going to replace with the capacitor. Now remember, you always need to make sure that the capacitor has the negative plugged in to the negative and the positive terminal plugged into the positive. Okay, so now the question I'm asking my students is this: what does a capacitor act like? I just took a switch 2 out, so now let's plug in the capacitor and see what we see. We see that bulb 1 was really, really bright and bulb 2 was off right when the switch 1 was closed. Right when switch 1 was closed, bulb 1 was bright and bulb 2 was off. So the capacitor acted like a closed switch. Right when the capacitor began charging, the capacitor acted like a closed switch. All the energy was delivered to bulb 1, none to bulb 2. But after enough time, what we notice is now we see that the bulbs are equally dim. So after enough time, the capacitor is now full. A full capacitor acts like an open switch. No current can go through it. But an unfilled capacitor, an empty capacitor that's just beginning to charge, acts like a closed switch. Current goes through very easily. So now that these light bulbs are equally bright, the capacitor is pretty much fully filled up. I'm going to take switch 1 out, so I'm going to open switch 1. Let's see what happens. And I don't know if it showed up on the video, I'm not sure, but that bulb was still lit for quite some time. Bulb 2 is still lit, but bulb 1 was off. Why is that? The reason is because bulb 2 is now receiving the energy that was stored in the capacitor through this circuit. This is the only complete circuit now because switch 1 is open. So when the capacitor has any charge in it, and it's in a circuit with no battery to make it charge up more, then the capacitor will discharge through any branch it can, still delivering energy to bulb 2. So this is a good demonstration talking about what a capacitor does immediately after the switch is closed, a long time after the switch is closed, and then how the capacitor can act like a battery.